Hi, in this video I'm going to introduce copy constructors and also shallow versus deep copy constructors. That is important for when you have a pointer as a member. Okay, so before we get stuck into the video, I'd like to talk about what is next in some of the upcoming videos. In this video we'll talk about the basics of copy constructors and then also shallow versus deep copy as I mentioned. And some of what I discuss in this video will also apply in the next video, which will go over assignment operator overloading. Then in the next video we'll talk about move constructors, and some of what we discuss in that video will be applicable to the next video where we'll talk about move assignment operator overloading. Okay, so just a few things I'd like to note on the copy constructor before we move on. The copy constructor for your class will be invoked when a new object is constructed as an exact copy of an existing object of the same user-defined type. So in other words, the copy constructor is invoked when we pass an object by value, return an object from a function by value, or when we initialize an object to an already existing one. Here you can see the copy constructor prototype. Instead of using type, I have class name here. Okay, because with a constructor it will have the same name as the class name, and unlike the destructor, we do not use any special symbols here. So again, it's just the class name, but then the important part is the formal parameter. So as a formal parameter, this has a reference to a class name constant, and this parameter is typically called other, or you can call it other obj, so for other object. Okay, we want to create a reference to that instead of creating a copy here. I'll talk about that in a bit more detail later. One final point here, the compiler provides a default copy constructor if there is no user-defined copy constructor provided. Okay, I'm using the entity class again for this quick demo. In the public section I have the constructor. Each time this constructor is invoked, it will do the console output entity constructor invoked. Okay, so just for demonstration purposes, you'll see why this becomes important here in just a second. Then I've overloaded the addition operator here. Notice that this returns the user-defined type, so a type of entity. Okay, this doesn't return a pointer, it doesn't return a reference. This is actually going to create and return an object. You can see right here we are calling the constructor. Okay, then I have this function here, getMember. These are again qualified as const. But the getMember function is simply going to return that member because I want to use it down here. Okay, so notice that the class body or definition ends right here. So this is not a member function. This is just another helper function, so toString helper function. It has a parameter called entity p just for parameter that is of type entity, and it's going to print out, so cout entity p dot getMember. So we are using that getMember helper function right here. And then in main I instantiate entity, I have entity 1 and entity 2. For the constructor I pass in 3, an argument of 3 for both of those. And then I have a result right here. And down here I do result, the assignment operator, entity 1 plus and entity 2. So we are using again the overloaded addition operator here. And then we do toString and we pass in result. Okay, build and run, we get entity constructor invoked 4 times, and this will print out 6. Okay, I mentioned previously that this operator that we overload, so right here, this constructs a new entity, so that is also going to call the constructor and print this line out, and it's going to return that object, basically a temporary object right here, and we're going to do member-wise assignment to assign the value of the member of that temporary object to the member variable of this result object. Okay, so I'll comment that line out. And now if I build and run this, the toString function will eventually print out 1 because the constructor has a default argument, which is set to 1 for this example, so member will be 1. Notice that entity constructor invoked is printed out 3 times now. Okay, so we sort of expect that. So I'll change things around a bit. Instantiate entity again. I create an object called result. That is basically copy assignment because you are initializing a new variable to an existing one, so you're creating a copy basically. Now for the fundamental types it's pretty easy, it's simply going to copy the value of x into y. But of course objects are more complicated because a class or a struct can have multiple members. Okay, I have the statement now, I declare result and I initialize that to entity 1. I'm just going to build and run that. This line printed out 4 times initially, then we went and we commented out that one line, and when we ran the program that time it printed out only 3 times, and now it prints out only 2 times. Again, this entity constructor invoked line. But you may be thinking, wait a minute, this formal parameter here am I not constructing an object when I pass in as an argument this object here? The same thing with this line. You can also say, well, am I not constructing this result object? And I'll just scroll up here. Remember that this is different because it is a reference to an entity constant. It is not a pass by value, it's a pass by reference. And that is true, we are constructing new objects, but we are not using the default constructor. So we are not using this constructor, okay? We are using what is known as the copy constructor. Currently we do not have one defined, so we do not have a user-defined copy constructor for our class, and because of that the compiler is going to generate one for us, and basically what that is going to do is it's going to do member-wise copying. And for this particular example, and for when you do not have pointers as members in your class, the default copy constructor that the compiler provides is going to be fine for the most part, because even if we go in and define one ourselves for that class, again, it's basically going to do the same thing that the compiler generated one will do for us. Okay, I'll scroll up to the class definition and I'll write a user-defined copy constructor. Again, this is the prototype of the copy constructor. I'll use the initialization list to set member to other.member. I'll simply print out entity copy constructor invoked, and I'm going to change in the default constructor. Actually, I'll just change this to make it easier to read. So in this constructor that also acts as the default constructor, we are going to print out default constructor invoked, even though we can actually invoke that passing in an argument as well. But this is fine just for testing purposes here. And then in the copy constructor, I'm going to print out copy constructor invoked. Okay, so just as a reminder, when will we invoke the copy constructor? Well, when we return by values, one example, such as here in this function where we overload the addition operator. I'll scroll back down to main, and also when you initialize a new object, in this case result, to an already existing object, in this case entity1. And then also when you pass by value. So here we do toString, we pass in result, the result object. Okay, here is the toString function. It has a formal parameter which is a pass by value, as you can see, so not pass by reference. And that again is simply going to print that out. So let's just build and run and see what happens. Okay, so now we get default constructor invoked. That prints out twice as it did before. And then also we get copy constructor invoked twice. So the copy constructor will get invoked right here. And then also when we pass by value. Okay, so now I'll go and uncomment that. This is fine. All we are doing is we are reassigning some value to result. And again here I'm going to use that overloaded addition operator. Okay, now we get default constructor invoked 3 times and copy constructor invoked twice. I'll just scroll up a bit here to this function. Remember that we are constructing this object right here. You might be thinking, why don't we get copy constructor invoked 3 times? Now this has to do with something called return value optimization, which is an optimization where the compiler removes temporary objects returned by value. And what we want to do for return value optimization is to construct the object that is to be returned in the return statement. We also have something called named return value optimization. That is where you have a named object in the body of that function and you are returning that. Now for named return value optimization, let's say you have multiple return statements. We want to make sure that they return the same object, the same named object. Okay, and then in that case, only that one object can be returned from the function. So I don't want to go into optimization too much. I'm only mentioning this so that if you go and test things by yourself, that you are not surprised by the results. Okay, so in this function here where we overload the addition operator, I'll make a slight change. Okay, I have this named object in this body now. So we do the construction right here. Actually, what I'll do is this. Okay, so here we are constructing this temp object and we are passing this. Here will return an integer that we then feed into the constructor. Okay, and then we return that. Build and run, and then what we get is default constructor invoked twice, then copy constructor invoked, then default constructor invoked again, and then we get copy constructor invoked twice again. In the previous run we got copy constructor invoked twice. I'll just go and undo a couple of times, build and run again, and you can see we get copy constructor invoked twice. Okay, so basically what happens is you construct one less temporary object. Again, a constructor constructs a new object. Okay, so you can imagine if you do this multiple times, maybe in a loop or in a recursive function, you can start to see that there will be performance gains from that. Okay, again, I don't want to get into optimization too much in this module, but in some cases I do, just to avoid confusion. So again, previously you might have thought, why does this copy constructor only get invoked twice? But also to explain why you would return like this to a return statement like this, where you construct the object right here, as opposed to doing a named object in that body and then return it. It simply has to do with there are some compiler optimizations. It's not just about reducing the amount of code lines that you have, because that's also what you'll often see in many people's code, is things like this, where you have the opening curly bracket. It's on the same line as the prototype, okay, that first line. Now I do not like that, and it really depends on the convention. So if you get a job somewhere, make sure that you adhere to their conventions. For some of them it would be, you have to write it like this. For others it would be something like that, okay? So again, it's not about reducing the amount of code lines and stuff like that. There are some reasons why people write their return statements and some other statements as well in a certain way. That often has to do with optimization. Okay, but we do have a copy constructor now. Okay, this here is the copy constructor. This brings me to the next discussion on deep copying versus shallow copying. And so I'll talk about that and the differences between that. And then I'll do another example for you on copy constructors. Before moving on to some of the examples, I'd like to summarize the difference between shallow copying and deep copying, just so that you can keep this in mind as we move forward. Okay, so I'll start off by showing you a few examples in the main function. So I just have a few pointers in the main function, but where we want to get at eventually is, again, object-oriented programming, and where you have pointer data members. And what happens to those when you create copies of objects? So we'll start off with the shallow copy here. During the copy operation for a pointer data member, only the address is copied from the source to the copy. Again, with an object you'll typically deallocate whatever dynamic memory that object's pointer members are pointing at, and you'll do that in the destructor. So again, we have the source and the copy now pointing at the same memory location, so both pointers store the same address. Now if you deallocate using delete one of those two pointers, then of course both will be dangling. Now let's say later in the program you try and deallocate one or the other pointer using delete. There's a good chance that the program is going to crash. Now again, hopefully you'll get a crash during program development so that you can go and fix that. And we'll take a look at some of the errors and crashes that you can get here in just a second. Now the default compiler generated copy constructor, and actually the assignment operator too, but I'll talk about that in the next video, performs a shallow copy. Now this is perfectly fine and acceptable if you do not have pointer data members. But as you can see here, if you have a pointer data member, then you can have crashes. Again, this can be a big problem. And that brings me to the deep copy. Following a deep copy operation, the source and the copy do not point to the same memory location. Each pointer will point to distinct memory, and the value that is stored is copied from one memory location to the other. So from one memory location, let's say it is pointed at by source PTR or source pointer, to another memory location, let's say that is pointed at by copy PTR or copy pointer. Okay, so this is just an introduction, a sort of summary for you, but I think it's easier to understand what's going on by looking at some illustrations. Okay, so here I have this example. In main you can see I have two pointers. In the first statement I declare source pointer, and then I allocate a new dynamic integer on the heap, and I initialize that integer to 3, and you can see the stack and the heap representation, just on a high level what this will look like. Then in the next statement I declare copy pointer, and I initialize that to source pointer, so that's going to copy the address from source pointer and store that in copy pointer. And then I simply do something with these pointers, so I print them out, I dereference them in these console output statements. Okay, but then the next thing I do is I have this delete statement, and I'm going to delete the copy pointer. Okay, and that's going to deallocate the memory pointed at by that copy pointer. Following the delete operation, the pointers that pointed at that location in memory, those pointers will now be dangling. And you can sort of see that with the arrows. they sort of point to the heap, but the memory pointed at by those dangling pointers should not be deallocated, and you should also not dereference those and try to assign some value to those memory locations, because they are not valid, right? You do not have a valid object in memory at that location anymore. So if you go and delete source pointer here, that's why I have that commented out, there's a good chance that you'll get a crash, but the behavior is actually undefined. And hopefully you'll get a crash during development so that you can fix that. But this is something that you should avoid. You should not delete a dangling pointer, and you should also not dereference and assign to a dangling pointer. Okay, so here's the example of the shallow copy in Visual Studio. I have two pointers here in main, source pointer and copy pointer. Those are pointers to integers. And for the source pointer, I'm going to allocate memory on the heap for an integer, and I'm going to initialize that integer object. And I'm going to store the value 3 in that memory location. And here I declare copy pointer, and I'm going to assign this to copy pointer. The address of source pointer I'm going to assign to copy pointer. So again, they both point now to the same object, which is on the heap. Here I simply do something with them, so I print them out. And here I delete copy pointer. Okay, so I deallocate the memory pointer to by copy pointer. Now both copy pointer and source pointer is going to be dangling pointers. And if you try and do something like that, hopefully you'll get a crash so you can fix it. This here will work fine. I can build and run. But let's just see what happens. Okay, I do this now. So I delete copy pointer. Again, that is going to deallocate that object on the heap that both of those pointers are pointing at. So both copy pointer and source pointer will be dangling following this statement. But yet I'm trying to delete whatever this is pointing at now. Okay, build and run. And you see you get some weird assertion, okay, some weird error here. Okay, this is not very useful in trying to debug your program, but this isValid heap pointer should hint to you that, okay, you are trying to deallocate memory that is no longer on the heap. But in general, it's not very handy, so I'll just abort here. And of course, you don't want to take any chances, you want to avoid this sort of thing. And as I mentioned, you can set these to null pointer. Deleting a null pointer won't really do anything. Your program won't crash when you delete a null pointer. Okay, if you do something like this, source pointer is null pointer, and I try and delete it, then we should not get an error. Or at least we should not get a crash. Okay, let's move on to an example of the deep copy. Okay, next I have this deep copy example. In main I have source pointer. Okay, that's a pointer to an integer, and I'm going to allocate a dynamic object on the heap. And then I have a comment here. This is the section where we do the deep copy. Firstly, I declare a new pointer called copy pointer, and in that statement I also allocate a new dynamic object on the heap, an integer, and I store the address of that new object in copy pointer. Then we dereference that source pointer to fetch the value stored in the memory that it points to, and we assign that value to the memory where copy pointer is pointing. Then in these delete statements we can deallocate copy pointer and then also source pointer, so we can delete one or the other or both. But the thing here is, and the difference between deep copy versus shallow copy, is that if I delete either one of these, only that pointer that pointed to that dynamic object on the heap will now be dangling, so not both pointers. Because again, with the shallow copy, both of those pointed to the same object in the heap, but here they both point to different objects on the heap, right? So this is typically the type of copy that you want to do when you copy with pointers, and especially when you copy objects when those objects have pointers as data members. Okay, I'm back in Visual Studio and I have an example of a deep copy. In main I have a pointer, source pointer. Okay, it's a pointer to an integer. Allocate memory for an integer on the heap again, and again I initialize that object to 3. Here is the example of the deep copy. So I'm going to create the copy pointer, and for that I'm also going to allocate memory on the heap for an integer. Okay, so this is where the difference comes in. I'm not just setting this pointer to point to whatever source pointer points at. Okay, so I'm not just copying the address of source pointer into here. I'm allocating space for an integer on the heap. So both of these point to their own distinct memory locations on the heap. Okay, and I want to make a copy, so that means I have to copy 3 now into the object here. And how do I do that? Well, I'm going to dereference copy pointer. I use the assignment operator, and I'm going to dereference source pointer. So again, this allows me to fetch the value stored in the memory location pointed at by this source pointer. So it's going to fetch the value 3, and it's going to assign that here to the memory location pointed at by copy pointer. Here I simply print those out again, and now I can delete both of those. And so if I deallocate copy pointer, it's going to deallocate that dynamic object that was on the heap here, and then also source pointer, that's going to delete or deallocate the dynamic object on the heap pointed to by source pointer. Now it's also a good idea to set these to null once you do this, because these are still dangling now right after the delete operation. But at least if you delete one, so if I delete copy pointer and not source pointer, then that's not a problem. I can still access source pointer. I can still do this here. Alright, I'll build and run. And you'll see that prints out fine. So we get 3 printed out 3 times. And of course you don't want to print out this now, because we've allocated that memory right here. Okay, so just a simple example using pointers here in main. And now we'll move on to an example with a class that has a pointer as a data member. Let's look at an example of shallow copying with pointer data members. I have the class definition to the left. In the private section you can see I have a pointer data member. I just call that member pointer. In the public section I have a constructor, and then right following that I have the copy constructor, the formal parameter being a reference to const. Now in the initialization list of the copy constructor, you can see what I assign to member pointer, and that is other.memberPointer. Now what will other.memberPointer fetch? It's going to fetch the address that is stored in the member pointer of that other object, so the argument that we pass in, okay, the object that we pass in as an argument. So it's simply going to fetch that address, and then it's going to store that address in the calling object's member pointer. So in other words, both member pointers are going to point to the exact same dynamic object on the heap. You'll notice what we do in the copy constructor is different from what we do in the constructor. The constructor with the default argument also acts as the default constructor, right? And you can see we allocate memory on the heap, doing new int, and of course it's going to store the address of that dynamic variable in member pointer. But again, in the copy constructor we don't do that. We simply assign the address from the member pointer of the object that we pass in as an argument to the member pointer of the calling object. In the destructor we do delete member pointer, and that of course is going to deallocate the dynamic variable on the heap that that member pointer is pointing at. And then I simply have this getMemberPointer function, and that's going to the reference member pointer, okay, and that is going to return an integer. Okay, here we have the main function and a helper function called toString. You'll notice the formal parameter for the toString function is a pass by value parameter. So it simply has entity and entity p again for parameter. And all we do in here is console output entity p.getMemberPointer, which again is simply going to dereference and return the member pointer. So in other words, it's going to return the value stored in the dynamic variable that member pointer points at. Now in main I instantiate entity, I create the object entity1, and I pass in 5 for the initialization. That's going to initialize the dynamic variable on the heap to 5. And then I can call the toString function passing in entity1. Okay, so when we call the toString function, that is going to push a stack frame onto the stack. And since this is passed by value, it's going to create a new object. Okay, entity p is going to have its own local members, in this case member pointer. So again, this doesn't reference the argument that we pass in. So in this case, entity1, it's going to be its own object. And so because of that, if you remember, I said when we create a new object as a copy of an existing object, then that is going to invoke the copy constructor. And that's exactly what's happening here. So we create a new object, in this case called entity p, okay, for entity parameter, and that is going to be created as a copy of entity1. And so it uses the copy constructor to construct entity p. And if you remember, the copy constructor is simply going to copy the address in entity1 now. It's going to do other dot, so it's going to fetch the address stored in that member pointer, and is now going to assign that to the member pointer in entity parameter or entity p. And because of that, both of those pointers point now to the same dynamic variable which is on the heap, as you can see in the illustration to the right. Okay, do console output entity p.getMemberPointer, and that's simply going to print out 5 to the console. But then what happens is that function returns. Okay, so we reach the closing curly bracket. Program execution will return to the return address, or in other words to the calling function, in this case main. We pop that stack frame off of the stack, which will also remove or destroy the local variables, in this case entity p. So what happens with an object that goes out of scope? So when you destroy entity p, well, it's going to call the destructor. And if you remember, the destructor is going to deallocate the dynamic variable pointed to by that pointer. Okay, so program execution is back in the main function now. And from the illustration on the right, you can see that we no longer have that dynamic variable on the heap. And so the member pointer, okay, which is a data member of entity 1, that is now a dangling pointer. And again, you might think this is not a big deal until you go and do toString again, or when you reach the closing curly bracket of the main function, in which case again the local variables will get destroyed. So basically right before the program terminates, right, you destroy the entity 1 object. What's going to happen is going to call the destructor. In the destructor you have delete member pointer, but member pointer of entity 1 is dangling. And as we've seen before, if you try and deallocate a dangling pointer, you are going to get a crash. And so this is why it's a bad idea to do shallow copying. So when you have a copy constructor that does shallow copying, in the case where you have pointer data members, so instead you want to do deep copying. But before we get to that, I'll just show you this example in Visual Studio. Okay, here is the entity class in Visual Studio. Can have the default constructor, which has actually a default argument, and then the copy constructor. Can we simply fetch the address? So here other.memberPointer, simply going to fetch the address from the member pointer of the argument that we pass in, and it's going to store that in the calling object's member pointer. And that's why the calling object's member pointer is going to point at the same dynamic variable that the argument's member pointer is going to point at. Okay, remember in the destructor we are going to do delete member pointer, get member pointer, it's const, and it's going to return an integer. In this case we are going to do reference member pointer, and here is that member pointer private variable. Here is the toString helper function. Now of course you can do something similar. Let's say you have a compound statement. Maybe we'll look at this here, an example just shortly. In main, again I do the same thing that I did in the slide. So I have entity 1, this object, I initialize it to 5. I do toString, pass in as an argument entity 1. That is going to use the copy constructor because entity P again is a new object that we are constructing as a copy of entity 1. So again, instead of using the constructor right here, which can also act as the default constructor, we instead use the copy constructor. That's simply going to print stuff out. When we return from this function, again, it's going to call the destructor of entity P. Okay, that's going to do delete member pointer. And then back in main, entity 1 will now have a member pointer that is dangling. And when we reach the closing curly bracket of main, so once the program terminates or right before the program terminates, it's going to destroy the local variables. So entity 1, and that again is going to call the destructor once more. That's going to try and delete member pointer, but member pointer of entity 1, remember now again is dangling, and so we'll get a crash. As you can see, debug assertion failed. Now just a second to recap what this assertion thing is. Here in this expression you can see is valid heap pointer. Now that is might remind you of booleans in the first module. Okay, so this basically checks to see is valid heap pointer. And of course if that fails, if this assertion fails, then we'll get an error or a crash. Okay, I'm going to abort that. So I'll talk about error handling in a bit more detail in a future lesson. Now of course if we comment that out, then the member pointer of entity 1 won't be dangling because we never do this here. And so when the program terminates, we call the destructor for entity 1. That's going to be fine because the pointer is no longer dangling. It actually will point to a valid dynamic variable on the heap. Okay, build and run, and you can see that works fine. It doesn't actually print anything in this case, but what it can do is we can use the getMemberPointer member function and build and run, and that will print out 5 as well. Or you can do this here. That will call the same constructor, which has a default argument of 1. I'll build and run, and that prints out 1. Now let's do something else here. Now you can do this using the assignment operator, or what you can do is this. And both of those are going to call the copy constructor, even though we've used the assignment operator, and that's because we are again creating a new object, and we are initializing that to an already existing object, so we're basically creating a copy. And because of that, you may want to use the syntax instead if that is confusing to you. And this will be more clear that, okay, this is going to use the constructor. In this case, the copy constructor. But once again, if I build and run this, firstly, it's going to print out something weird. It's stalling, okay. Finally, it says any key to continue. So it's unexpected behavior, it could crash, and so on. And the same thing that happened when we call the toString function is going to happen here. Entity2, okay, its member pointer is going to point to the same dynamic variable on the heap that entity1 points at. But remember, this is a compound statement. Once we exit or reach the closing curly bracket, it's going to destroy the local variables, in this case entity2. Entity2 will call the destructor, which is going to deallocate that dynamic variable, okay, on the heap, which both of these point to, and that's why you get weird or undefined behavior, and it can also lead to a crash. Okay, so I hope this was interesting. I know this video is getting a bit long, but you can see from this example why it's a bad idea to do shallow copying when you have pointer data members. And so to end this video off, we'll look at the same example, but we'll do a deep copy instead. Okay, so a few slides again, and I'll walk you through a few illustrations. And to start off with, to the left we have the entity class again. You'll notice the only difference is that in this case the copy constructor does a deep copy. In the regular constructor we allocate a variable on the heap and assign its address to member pointer. And you'll see we do something similar in the copy constructor. Okay, we allocate a dynamic variable on the heap, an integer. Okay, and with that being successful, it's going to assign that address to member pointer. Now, if you remember from the shallow copy, all we did is we copied the address from the other object's member pointer to the calling object's member pointer. Okay, so we did that assignment, and both of those then pointed to the same dynamic variable in the heap. But now in the copy constructor we are also creating a dynamic variable on the heap. And then to copy the value, what we do is similar to what we've done in the previous deep copy example, which was just in the main function. Here we do something similar again. We're going to do reference member pointer, and then to the right of the assignment operator we do other.member pointer, and then we dereference that. Okay, so that's going to fetch that value, and it's going to assign that value or store that value in that dynamic variable on the heap that member pointer now points to. That is the member pointer of the calling object. And the destructor is going to be the same as in the previous example where we did the shallow copy. So again, it's just going to delete member pointer. Okay, I have the toString and the main function again. In main, I instantiate the entity class. I create an object called the entity1. This is going to use the regular or the default constructor. And the default constructor again is going to allocate a dynamic variable on the heap. And it's also going to initialize that variable on the heap to 1. Now next is where that deep copy constructor comes in handy. We call this toString function and we pass in entity1 as an argument. Okay, that will push a stack frame onto the stack for that toString function. Again, this is passed by a value. In the parameter we instantiate entity, we create an object called entityP. EntityP is a new object and we are going to initialize that to entity1, okay, that we pass in as an argument. And so because it's basically a copy of entity1, again we are going to use the copy constructor. Now if you remember, in the copy constructor we also allocate a new dynamic variable on the heap, and then we dereference the member pointer of the object that we are constructing, in this case entityP, and we use the assignment operator to assign the value that is stored in the other object. Okay, so the argument, in this case entity1, so it's simply going to copy the value 1 from the dynamic variable that the member pointer of entity1 is pointing at to the dynamic variable that the member pointer of entity P is pointing at. Okay, in the toString function again we do console output entityp.getMemberPointer, so we do that getter again. We reach the closing curly bracket of that toString function, and then program execution will return to the return address to the calling function, which is main, and then we pop that stack frame off of the stack. So of course this means the local object entity P is going out of scope, and that means that the destructor is called, which has the statement delete member PTR, which again will deallocate that dynamic variable pointed at by member PTR. And so program execution is back in the main function now, and you'll see that basically nothing has changed. It's as if we never called that toString function in the first place, because the member pointer of entity1 is not dangling. It is still pointing to valid memory, it's still pointing to the dynamic variable which is on the heap. This means when we reach the closing curly bracket of main and that object goes out of scope, so we clean up our object, that is right before the program will terminate, then entity1 will call the destructor, and that is going to deallocate and that dynamic variable which is on the heap. Okay, we don't have any problems with that delete operation because it is not a dangling pointer. And this is the advantage of doing a deep copy as opposed to doing a shallow copy. Even though again this is just a very basic high level example. Okay, again, just in case you are still confused on this, let's go and look at this in Visual Studio. Okay, I'm back in Visual Studio. I have the entity class again. We do the regular constructor. It's weird calling it the default constructor, but it basically also acts as the default constructor. Again, it just has a default argument. Okay, we do the copy constructor. This time it's a deep copy constructor. You can see it's very similar here since it allocates a dynamic variable on the heap, just like in the default constructor. Okay, and the statement again, this is simply to copy what is in other.member pointer. So we dereference that, and you don't have to do it in this way. You can do it like that. I just did it in that way to make it easier for you to read. So this will work fine. Okay, it's going to dereference member pointer basically to fetch the value stored in that dynamic variable that's on the heap, and it's going to store that here to whatever member pointer is pointing at, which will also be a dynamic variable on the heap. Remember that a constructor is invoked when we create a new object, right? So whether it is the default one or whether it is the copy constructor. There's a difference between assigning something to an already existing object and creating a new object. Or maybe creating a new object and having that be a copy of an existing object. You have to take these things into consideration, and I'll continue with that discussion in the next video, where we'll look at how we can overload the assignment operator. Okay, we simply have the destructor again, and getMember pointer, that getter, he is the toString function, and then he is main, so again entity1, toString, I pass in entity1, so it's the same as what we had in the illustrations. You'll see this works fine, we don't get any problems. As I mentioned, of course, this is just a simple example to illustrate a copy constructor and the difference between shallow copying and deep copying to you. But here's an example of where deep copy is useful. So instead of doing toString once, I can do it multiple times, and we're not going to have any problems, right? I can build around this, and you can see it's going to print out 1 each time. It's not going to crash or give us any weird behavior. And that's simply because each time it's going to create entity P as a copy of entity 1. If I scroll up in the copy constructor, again, it's going to allocate a unique dynamic variable on the heap, which is going to assign to the member pointer of the object that is constructing, in this case member P. And again, it's simply going to copy the value over, okay, from one dynamic variable to the next. And that's where we don't have a problem. Just one final example for you. In a previous lecture, we discussed delegating constructors and how a constructor can delegate to another constructor. So I'll scroll up here to the copy constructor, and you might have thought about this yourself. So of course we already have the default constructor right here. So instead of doing all of this, I'm going to change this copy constructor to a delegating constructor, and it's going to delegate the construction to the default constructor. Okay, so this is how we do it. We do entity, parentheses, and then we can do other.member pointer, and then we dereference that. So we want to fetch the value that is stored in the dynamic variable that this member pointer points at. That is going to return an integer, and of course the default constructor takes in an argument, okay, an integer as an argument, and it's basically going to do the same thing that we did before in the copy constructor. Okay, it's going to create a new dynamic variable on the heap and assign that to the member pointer of the object that we are constructing. And I'm going to pass in that integer that this returns right here into x. We'll represent that, and we do that initialization in this way instead of having a separate statement, a separate line to do that as we had it in the copy constructor before. Okay, so this is now a delegating copy constructor. And if we build and run this, this will work fine. So I know this was one of the longer videos, but having a deeper understanding of these sorts of things and how to manage memory and so on, that really is important, so I'm taking my time to try and explain it to you properly, using again a combination of illustrations and examples in Visual Studio, so you can actually run it and see what's happening. And with some perseverance, if you just keep going and you just keep learning, just keep going, play around, try and understand what's going on, and that's going to separate you from, the average programmer that doesn't have a deeper understanding of C++. It's going to take some time to finish all of the videos and stuff. We have more constructors and operator overloading and stuff to talk about, but just try and understand what's going on. And then when you get to game development or something else, when maybe you go into Qt development, you have these foundations down, right? Then it's going to be easier for you to go into those directions. Okay, I hope you found this lecture useful, and again, I'm going to see you in the next video. We will talk about overloading the assignment operator